given the integral from 0 to 9 from f of x, the integral from 0 to 9 from g of x, and they want us to determine this. Okay, so obviously I know that the integral from a sum is the sum of integrals, and I also, so I will write 0 to 9 from 2 f of x dx plus the integral from 0 to 9 3 g of x dx. That's the first property that I apply. Now I will move the constant in front to the integral from 0 to 9 from f of x dx plus 3 the integral from 0 to 9 from g of x dx. And I know the answer because this is given to us as being 37 and this is given to us as being 16. And I'm lazy tonight, so what do I get there? Is it 74 plus what is it, 48? Correct me if I'm wrong. I got 122 as the final. Okay, since you didn't say anything, I'm assuming that I'm correct. And now we want to go back because I gave an example of a function, the integral from 0 to 1 from e to negative x squared dx. And I said we cannot find the antiderivative of this, but we can still come up with an approximation. So the integral from 0 to 1 e to negative x squared dx. We cannot find the exact answer for this because we can't find the antiderivative without a mathematical software. Okay, so then I have to decide how many subintervals. I want a better approximation, I want an okay approximation. So if I want a good approximation, I should use at least 4 subintervals. And we're going to use the midpoint rule. We just used it. I didn't tell you it was the midpoint rule. Okay, so what does that mean? It means that I divide the interval between 0 and 1 into 4 equal pieces. So this is 0.5, this is 0.25, and this is 0.75. And I would say this is approximately base, which is 0.25, and I will leave it alone outside. And the function is e to negative x squared. So I would say, I would like to write f first. So sorry about that. I want to write f, and I may need more room here. Okay, so this is f of right here in the middle. 0.25 divided by 2 is 0.125. So now here, 0.125 times 0.25, this point will be 0.375. And now 0.25 plus this is 0.625, and then 0.25 plus the 0.12. Okay, so this is 0.875, of course. Okay, so the function evaluated 0.125 plus the function evaluated 0.375 plus the function evaluated 0.625 plus the function evaluated at 0.875. Of course, I'm not going to do this by hand. I'm going to edit my lists like we did before. Clear. So these are the numbers that I need to plug in as x values: 0.125, 0.375, 0.625, and 0.875. And now in list L2, I want to put 0.25, and I want to put E, raised to, in parentheses, minus, list L1 squared, and close the parenthesis. I want the calculator to give me all these numbers right away, meaning this times this is going to be on the first row, second column. This times this is going to be in the next one. This times this, and all of them would follow. So I'll press enter, and I get all those four numbers right away. And now I just want to create the sum of these numbers, and I have an option. There are other options. We go to stats and calculations. And we want list L2, and I just want to calculate, and I need the sum, just the sum. And that is the area under the graph using the midpoint rule. 0.748747. So although I cannot determine the function whose derivative is this, I cannot, I can still get an approximation of the area under the graph of this function between 0 and 1 using the midpoint rule. And what I did was I divided the interval into 4 because we decided to use 4 subintervals. I determined the midpoint for all the subintervals, and I said base times height, base times the function value at that point, times plus base times the function value at that point for all 4 subintervals. And I created a list, 2 lists in the graphing calculator. I put these numbers in, and then I calculated the product. And this was the function e to negative x squared. So this is a good approximation of the area under the graph of e to negative x squared. We always have a way around it. We can always evaluate. It may not be, free of errors, and it can be free of errors, but we can always have the option of determining an approximate value for any integral. Okay, I'm looking to see, we have a few minutes, 5-6 minutes left, 7 minutes. So let's take a look at something else. Yes, let's look at another property, how we apply one more property here. So I'm looking at problem 56 on page 384. And they're asking us to show that this is the case. We're not asked to evaluate anything. And for this one we have a technique right now, but for this one we don't. You have to wait till Calc 2. So, but we're not asked to evaluate anything, we're just asked to show that this is less than that. So this is basically the property that if I can show this, if I can show that this function is smaller than this function, then the integral will follow by one of the properties. So first of all, I have to start with the interval 0, 1. So I know that the function, the x value goes between 0 and 1. That's clear. Lower limit, upper limit. So x goes from 0 to 1. Okay, so now because x is between 0 and 1, is a number like, let's say, 1/2, 1/4, 1/3, and so on and so forth. It's between 0 and 1. And when I add 1 to all three sides, I get this. Right? So x plus 1 will be a number between 1 and 2. Because everything is positive, only in that case, I can apply the square root. So I know for now that the square of x plus 1, I don't care for this side, but I know that the square of x plus 1 is a number less than or equal to the square root of 2. Now, I'm more interested to compare this. So when we have x between 0 and 1, we know that x squared, right, will still be between 0 and 1. So when I add 1 to both sides, all three sides if you want, I have x squared plus 1 is less than or equal to 2. I take the square root, and I haven't gotten too far. This will not give me a comparison. I only know that both of them are less than or equal to the square root of 2. But the question is, what will really be the relationship between x plus 1 and x squared plus 1? Only when we talk about x between 0 and 1. So this is a number definitely bigger than this, because when I square 1/2, I will have a number less than x. So if x is 1/2, x squared is smaller than this. This number is the same. But because x squared is always less than or equal to x for 0 to 1 only, then the left-hand side must be less than or equal to the right-hand side. Because if this is 1/2, this is 1/4. If this is 1/3, this is 1/9. If this is 1/10, this is 1/100. So this number will always be less than or equal to this number on the interval 0, 1. So that's all we needed to show. And of course the square root will follow, is the same thing. And that's all we needed to present.